So that's my talk, Stairway to Heaven. It's a bit on the offensive side of the track, so if you're here for defensive, it's kind of offensive, but you will all get it. It's really low level in the tech part, so I will keep everything on track. What am I? Who am I? I'm a pen tester, I'm a red teamer, I'm a cloud enthusiast, I'm a Linux nerd. I work a long period of my life in cybersecurity. I did cybersecurity before I worked in cybersecurity, so there's that. I studied math. Don't ask me why I studied math. I'm not so sure either. There's not much left anymore, but it's what it is. So I founded Lutra Security. Lutra Security, we founded Lutra Security. These are the 4 founders of Lutra Security. Lutra Security is a penetration testing company. We do penetration tests, more or less everything what you can do with penetration tests. We do cloud security, that's mostly my part. We do red teaming assessments in the cloud, on premises, everything else. We do much more. We also do physical assessments. We break into banks sometimes. And this is what we're doing. So much to the who I am. Now what you will see, what you have to expect. This is the table of content. We will see this markers many times during the slides to see where we currently are. Why is this so? Because we have planned a zero to hero story how we hack a cloud. We go from unauthenticated to full compromise of a cloud environment. Before we can do this, we need some preparation. The preparation is, what is the cloud? Just to get everyone on track. And what is the motivation? Why are we doing? What are we doing? And then we see a quick example, pawned by metadata. It's a super nice example from my earlier CTF. It shows why it's important to have cloud expertise and not just standard pen testing expertise. Because there are some topics, some things that are really different within the cloud. And then afterwards, we give some short advice. During the talk, I will show you what went wrong when we hacked something. So this is something you can take with you. This is more or less the defensive side of the talk. You will see what we hacked, what misconfigurations or what the problems are in the cloud environment. And then, after the advice, if you have time, I don't think we have time because the talk is originally planned a bit longer, I could present you some goodies, but I'm not sure if we should manage it. So, to get you on track, what is the cloud? When we talk about the cloud, we don't talk about software as a service. We don't talk about cloud applications that are managed by some other company. We talk straight up about cloud native applications and services, AWS, Azure, and things like this. Sometimes, and there's a bit of a leeway, we also talk about Kubernetes. This is more in the part of hybrid clouds or private clouds, but most often you also have Kubernetes in some public clouds. So this is something we take into the cloud aspect. In short, the cloud is just some other's computer. My pointer is not working, I think. Nochmal? Nope. That's good. This is why we are doing it. The breaches, the cloud breaches. If you look in the news, you have many articles that are like this. January 2024, Microsoft breached by Russian group. Security news, LastPass hack. Chinese hackers breach US agencies. Microsoft again. 6.5 terabytes of data exposed in an unprotected S3 bucket. One of the better things to find as an attacker. Former AWS employee convicted. Classical insider threat. Now, again, an exposed S3 bucket with a bit of data. Uber just got compromised, also S3 data store. pharma giant, data leak, cloud misconfigurations. So, in short, breaches everywhere. More or less everyone can get hacked via the cloud. More or less everything can be hacked within the cloud. Just have to know what the problem are. This is the motivational image. Keep this in mind. This is why we are here. What are the problems? Especially in the cloud, there are a lot of service providers. Just to name the three biggest ones are AWS, Azure, and GCP. They all have kind of a similar concept, but they all do things different. Every service, and there are thousands of services within each provider, and every service needs to be configured. Most have some kind of standard configuration that is already pretty good, but most of the time you do need to have a good configuration. And the third problem is everything works really, really fast within the cloud. It's modern, it's really fast evolving. A few years ago, the problem was even harder to keep up with the development within the cloud landscape. But this is the most, everything boils down to you have many potential security issues because you do not have the expertise within the companies most of the time. You have developers for on-premises software, but most of the skills, or many of the skills you need in the clouds just don't transform that well. So you just need to keep up with the expertise. You have to find developers or train your developers that they can also, or they know the vulnerabilities within the cloud. Another big problem, most of the time, cloud comes with some kind of shared responsibility model. It's not just, most of the time it's more or less always, because the cloud is just shared responsibility. You go to a cloud provider because he makes many things for you. But the problem is, many think we have everything in the cloud, so we are safe. That is not the case, because just you do have less things to do in administration, but the less you have in administration, the more you have in configuration, more or less. So you do really have to do your responsibility. Cloud is shared responsibility, but not no responsibility. What do you need to hack? This is what do you need to hack in general, more or less. You need a fundamental cloud security knowledge. You need expertise in all the cloud or many cloud services. You need to have a tendency to think outside the box. It's really, really important because you must break out from the thinking you are on premises, you are now in the cloud, and there's so much more possible. Most of the things that are possible on premises are possible in the cloud, but there are so many things that are possible just in cloud environments. And of course, you have to have fun at abusing unintended behavior. And as a bonus, it's really good if you have a spare Guy Fawkes mask and a black hoodie. 90% of the job. The common pitfalls in the cloud are bad permissions, leaked secrets, and hidden cloud-native features. These are mostly pitfalls that you can have in on-premise software, but they are escalated within cloud environments. And these are the things we see most often within cloud environments. Bad permissions, you have some policy that you assign the service, you don't really know what the policy or the permission set does, what it means if you assign it to something, and then you have many weird combinations that allow privilege escalation within the cloud. Leaked secrets, I don't think I have to say anything about leaked secrets. Hidden cloud-native features, I will explain in a minute, because we see an example what I mean with hidden cloud-native features. Or it's more like features that a developer or even a pen tester does not know about. There are many such things in cloud environments because there are so many things that are just in the cloud. And if you don't know them, you can miss them, and they can be a huge security leak. All these things we see in the common slides. So let's just start with the first one. The hidden cloud-native features. This is the point by metadata topic. It's a CTF, or it was a CTF. The premise of the CTF was you have access to a GCP instance on Google Cloud. You have a shell access with an unprivileged user. It was an easy capture of the flag, so everyone should be able to follow. The problem with the CTF was that most of the ones that are not cloud expert, or the participants that are not used in breaking the cloud, did fail at the challenge, even though it was easy, because you don't get at it like a normal challenge. We see this. So the premise was, we have to get to the root user. This was the challenge on this machine. We have two ways. We have one times the traditional way, via Linux misconfigurations, some services that are exposed, kernel exploits, Spectre, whatever. It was a completely managed GCP instance. There was nothing on it, no services exposed whatsoever. So this was not the way to exploit this thing. And it was a cloud challenge, so it was clear you have to do something else. But this way it didn't work. So we look at the cloud native exploits. And the cloud native exploits, there are many. So what do? We just need to look at what do we have. And this is one of the hidden features I told you about within the cloud. Within a GCP instance, or more or less within any instance, cloud instance, you do have some kind of meta service. These meta services are used for privileges. If you want to assign privileges to your EC2 instance or something like this, these are to boot up with some special configurations. There can be anything inside these metadata. And these metadata services or APIs most often have some kind of token on the instance. And this token can also be used on a GCP instance to just query the G-Cloud API. This is what we do here. We list G-Cloud out of list. We see, okay, we have some account that is called Vault27 whatsoever. Next, we want to do something with this cloud account. It's a nice account, though we should use it. So we could not really list our permissions, but it's not the problem. We just see what are the roles in this project. So the roles within this project are roles Vault Manager. So if this is the only role, and suppose we have a role, we are most likely having this role. So this role has the following permissions. Not really much. You can see the roles, you can get the roles and list them. This is what we just did. And you can get and set the metadata. So the metadata, getting the metadata is probably fine because you want to have the metadata on your machine and access to the metadata. Setting the metadata is really not so fine. What is in the metadata? I told you about. But what's also in the metadata, or what can be in the metadata, are SSH public keys. These SSH public keys do one thing if they are in the metadata. Google Cloud automatically assigns a new user to your machine that has pseudo privileges on your machine and which can log in with this public-private key combination. So if you can't write the metadata within a Google Cloud instance, you can just give your new user that has pseudo rights. This is what we are doing here. We just generate a new SSH key. We publish the SSH key. We write the meta.txt file in the correct format for GCP, and then we just add it to the instance's metadata. All from within the Google Cloud instance. We didn't need we need a computer to access the Google Cloud instance, but everything else runs in the cloud. And then, afterwards, we can just SSH into this machine, and we see now we are Vault admin, we have sudo rights, and we are the root user. And this is something I call the hidden cloud features, because first, these metadata services are not that well known, and second, these are also permissions. Set metadata, nobody knows that set metadata allows allows to access to a GCP instance with root credentials. This is not something you would expect from a permission that is called set metadata. It's somewhere in the documentation, of course, it's written there, but you need to know it, or you at least need to find the hint. So, next on the menu is our Zero to Hero story. What are we doing? We try to access Megacorp's AWS account. Full compromise, whatever they have, we want to have. The starting point is unauthenticated, so you need to break in. more or less black box. We do not have really much information. We have the correct AWS account, but that is it. We have more or less 25 minutes. We have 24 minutes right now, so we have to speed up a bit to get through it. So what do we have to do? Our plan, it's more or less always the same plan when we get to something to hack, when we when we are assigned a job. Then we need to enumerate. I will spare you the details. The enumeration part is more or less the boring part. We just need to look at it. What have you? What can we hack? What are the systems? Most of the time we get some kind of information about the systems. For example, the AWS account we need to hack because this is the scope. We do need to have this information. Otherwise, we will attack the wrong target. The next step is initial access. We just get to in somehow. We need to gain a foothold. This is really important because then we can escalate. If we don't have anything, nothing is there. And then the privilege escalation. We don't want to have just a regular user account. We want to have everything. This is the job. This is the flag that we have to get. And then afterwards, we will see what you can do afterwards. For the initial access, there are a whole lot of options. And this is the part where the enumeration is important. You just look at everything you get, everything you find, and then you think, okay, can I hack this? Are there any security problems with this? And whatsoever. Sometimes it's easy, sometimes it's just an OpenS3 bucket. We have this on the first breaches slide, and sometimes it's a little harder. It can be an authenticated EBS snapshot, which you can just download. It's more or less a snapshot of a virtual machine. And in snapshots of virtual machines, there can be really juicy details or just some secrets in a GitLab, in an open GitLab, in some repository whatsoever. Or even just vulnerable applications that run in the cloud. This is the path. The path is relatively straightforward. This is what we will see in the next few minutes. We start unauthenticated. We will find the AWS ECR registry where we will find something that provides us credentials. These credentials allow us to access the WordPress pod. Pod is a thing, I'm not sure how technically we have to go there. But more or less, the whole green area is a Kubernetes cluster. The Kubernetes cluster is based upon VMs in AWS, in EC2 instances. And on each of these VMs, they are running multiple pods, each pod for some application. In this case, the pod is just there to provide a base container for the WordPress instance. Then we need to escalate from the WordPress instance into the cluster node, and then we will see again how we get into the AWS console. This is the path. I told you that we will start with the public ECR registry. This is the first step. This is really pretty easy. You need the account ID and you need the correct command, and then you can look at the public images of an AWS account. And here we see, okay, they have a public image, public container image, Docker image. So what is in this image? Well, just let us pull it. It's standard Docker pull, nothing hacky here. That's just what every developer does when he pulls an image. And then we get the image. And then we can investigate it locally. What is on the image? Are there any files? Are there any secrets? Is there anything on this build image? The first thing we can do is, how is this image built? This is the history of such an image. In the history of such an image, there's everything you did when building the image. It's not really easy to read here, so we need to format this. But these are all the steps that happened in the lifetime of this image. If you just format this and pick out the correct lines, then you will see, oh, there are environment variables within the image. It's for megacop WordPress prod DB name, DB password, really nice password there, and the DB user is root. How did this happen? Well, in short, this is how you do this, or this is how you don't do this. You do not keep your environment variables in Docker files, straight up. You do, or you can have environment variables in your Docker file, but just not secret environment variables. Most of the time, if you do not have a secret management solution, this is one of the solutions the developers come up, because it's just in the Docker file, and afterwards it's a build image. Nobody sees what's in the build image. It's just magically there. But the problem is everyone can look at the build image and can look what's there. And this is the problem here. So what are our options now? We have a few different options when we get secrets. We can try to access the database directly. Most of the time, databases are not exposed to the internet, so it's not that good for initial access. But what if we look at the password again? It's so a nice password, so random, so long, and we know they do not have a secrets management. So what about if someone said, oh, this is a nice password, why don't we use it again? So in this case, it was really a case of password reuse. We could just log into the WordPress instance with the password as root user. And this is, I hope we see this now. This is a demo. It's the slowest speed run to hack WordPress. How we get from the WordPress instance with credentials into a shell that is on the WordPress pod. I hope this video works. Nice. So we just are on the WordPress instance. We scroll a bit around. We look at it. We see, OK, nothing to find here. So we guess, OK, can we log in? Of course we can log in. Let's try it out. And nice, the password indeed was reused. And now the real hacky part comes. We get to plugins. We see, oh, there are nice plugins installed. We just add a plugin. This is some kind of plugin you can freely download within the internet. From the internet, we uploaded it, we activated it, and we have a nice shell on the WordPress pod. Just to confirm, we are a user, and we can access the whoami and the id command. So this was the hack. This is how you get the shell to WordPress or the WordPress instance when you have credentials with these rights. So now we are much a bit further in the process. We found the image, we found credentials, and now we are on the WordPress pod. Next step is to escalate to the cluster. This can be really tricky. And this is a really hacking-looking picture. This is what we have to do every day. Look at console output and get a grasp of it. This is all running on the pod. Like everything else, we need to have confidence with what are we working here. What we see here, I just ran the processes and I listed the Linux capabilities. What the Linux capabilities are is not much of a concern here. It's just what can I do within the Linux system. You can really restrict this in a container, but in this case, they didn't restrict it, which proves more or less that we run in a privileged pod. What this is, we will see in a minute. The first thing is, just the PID1 is interesting here. The PID1 is not the PID1 you would see in a Docker container. The PID1 is the process from the surrounding node, from the surrounding EC2 instance. This means that host PID is enabled and we are privileged. This is more or less overkill. It's always overkill and is more or less the worst you can do to a container, because this means that you just can really, really easily escape. How did it happen? Well, we see here a new cluster is created, and the last thing is more or less the problem here. You just run a pod, it's called vuln pod here, with the privileged command flag and with the override host PID true. These are two command flags you have to set manually, but they are many times set because they are just the easiest to get working. Because then your application can do everything it could do in a VM. In a container, some things are prohibited. In a VM, more or less, most of the things are allowed. So, but what does it mean? What happens when we have privilege and host PID? Well, we see it here. We see in the first line that we are on the vuln pod, and we see in the second line we make an NS enter, which just is a namespace enter, which is possible because of the host PID. We enter in the namespace 1, which is the namespace of the node, and then we see we are not anymore in the pod, but we are on the node. This is one command to rule them all if you are on a privileged pod with hostpit. This is the most basic way to hack such a pod and to escape to Kubernetes. They are on the slides if you are interested. In the goodies section afterwards, there is another escape you can do from a Kubernetes pod to the Kubernetes node. But this one is the easiest one and is the easy one to present. The other one is a bit more technical. So now we are on the cluster node. Now we are already in AWS. This is an EC2 instance. This is running in the cloud. This is part of the flag already completed, part of the job already completed. But now we want to get credentials to AWS. Again, there are a myriad of ways, but most of the times you start by just seeing what can your instance do. Most of the times, like before, these instances have some kind of service account, and this service account, again, in GCP, in AWS, all the same, they can access some kind of metadata API, and this metadata API has some token, and this token can also be used to access the AWS API. This is what we're doing here. We just get the token. This are just some basic commands that you can do always. You need to get the token. We make a quick curl, and we test the token, and the token is valid. And we see in the next instance, we see that we just can use this on our hacker machine. We don't need to have this token on the EC2 instance. We just can pull it out, pull it from the machine, and then work on the AWS instance. This is really important because in this case, if you get a valid token to access the AWS API, the API is public. If you want to hide from everything, EDR or something else, you can do everything on your machine. This is not running in the cloud. This is running in the cloud because AWS will see what we are doing, but AWS will not care if we hack your machines. So this is really cool for us because we can do everything more or less silently. And then, third time's the charm. We just need to do enumeration again. What can we do with this token? In AWS, it's a bit tricky to get the privileges of your token, so you just have to brute force the privileges. In short, you try every API you have, and AWS will tell you if you can access the API or not. In these cases, we have 3 things we can access. DynamoDB describe endpoints. I'm pretty sure every token in existence can access DynamoDB describe endpoints. I'm not sure why, but it is like this. The other 2 are more interesting. EC2 describe instances, we can list every EC2 instance. But the third one, secrets manager, list secrets. This is a really nice permission. If you have access to the AWS secrets manager and can list the secrets, you're pretty fine. If you can look at secrets in secrets manager. There are most of the things you store in the cloud if you use the secrets manager. So it's a good starting point. We should look at it. But if you look at it, there weren't secrets anywhere. That's a shame. Because if there are no secrets, it's a rabbit hole. We have to do something else. More or less, we knew that they have no secrets manager or that they don't use secrets manager because we saw that they have the secrets within the credentials within the Docker file. But nevertheless, if you have a token with access to secret manager, it's a bit of a disappointment if you're a red teamer and just get no secrets whatsoever. So you think, what can we do? And then these are something I called the hidden features. You think, what if there's a reason why they have this permission there? What if they used it, but just didn't think it works for them? So, what can we try? Well, we list the secrets with include plant deletion. This is a feature flag from AWS. It lists secrets that are to be deleted, but are not yet ready, already deleted. If you delete the secret, the following happens. This is a quote from the AWS documents. If you run the API command delete secret without any feature flags, this is what happens. It deletes the secret and all of its versions. You can recover with a recovery window during which you can restore the secret. The minimum recovery window is 7 days. But the default recovery window is 30 days. 30 days after you deleted the secret, it will be somehow available. And this is where you have to look in the documentation or where you have to know it. These are things you will not get if you try to delete something. It's gone. You don't see it in the console. You just see it with the API. It's a bit awful. So we know there's a deleted secret. We try to get it. We get an error. OK, it's deleted. This is how it should behave. But what if we just restore the secret? It's restorable for 30 days. So yes, restore secret, easy enough. And then, what do we have here? Get secret value, secret ID, AWS prod, and we see the secret string. In this case, it was a secret for the AWS console, or so we hoped. We see it's a username and password, and we just wanted to make sure that it's for the AWS console. How do we do this? Well, we know the account ID, we know the username, we know the password. We cross our fingers, and then we got access to the AWS console. Job done in less than 25 minutes. And this was more or less the complete story from zero to hero. And afterwards, we feel like real hacker now. We are the hacker man, and we are in, the famous quote. What now? This is the thing where we profit. Well, we as ethical hackers, morally good penetration testers, we are just writing a report, 100 sides of paper, more or less, most of the time. Other ones will start here. You have really, very much possibilities in the cloud, more or less, or everything you can do in on-premises systems. What you can do, crypto mining, easy. Just run a few GPU instances for some money, some huge money, and as long as you don't flag the budget, you can mine everything you want. Ransomware, we had a real cool talk about ransomware. Ransomware in the cloud is also a thing. In the cloud, everything is encrypted, more or less, or is easy to encrypt. Every service, every S3 bucket, every database service has a way to encrypt something. If you have access to the AWS account with high privileges, you can just, for once, delete the keys or assign the keys to yourself. Then you are the only one who can who can decrypt these. Or persistence, thousands of services, more or less everyone can be used to persist somehow. You can schedule jobs, you can inject configs, switches. The world is your oyster. You can do more or less everything, and you have to have a really, really good cloud environment and a really, really good blue team that these guys are finding what you did within the environment. So this was the path. We started with the AWS ECR container. We got credentials, got in the WordPress pod, got in the cluster node, saw a secret manager, saw deleted secrets within the secret managers, and then we got access to AWS console. Pretty easy, pretty straightforward. In a real job, it's not that easy and not that straightforward, but it's just for you to better feel what it is and what are the common pitfalls that you can find within these cloud environments. Some advice, just one last slide. I cannot tell you, we have around 10, 20 presentations about what you can do to get around these things, to prevent such things. So please go to the talks, hear them. It's always cool to hear the other side. I cannot give you the all-compassing information how you stop us. It's really not possible. There are some things you should do. If you don't do them, always use least privileges. It's really important within the cloud because we saw there are some privileges. If you don't know what these privileges do, please remove them. Because every privilege more or less can be used to escalate something in the cloud. So privileges in the cloud are really, really important to have the lowest possible privileges at all. Tokens and credentials, we saw two things where it went wrong. We saw tokens within a credential in a Docker file. This was really, really the wrong way. Security managers would be some kind of right way, but security managers also have some features that you would not expect. So just be sure that your tokens are safe. And MFA, especially for single sign-on accounts, everything is running with single sign-on nowadays. We have AWS. You can access AWS with Microsoft accounts. You can access Microsoft with AWS accounts. Just if you have such high privilege accounts, then use special tokens or use multi-factor authentication. And really, really important, the security tools. These slides, I'm pretty sure you get them after. Yes, you get them afterwards. On the slides, there are a few open source security tools. There are so many security tools, and in the cloud, you need them. This is really important because the cloud is so huge, there are so many services, and this is really only possible to grasp if you have some kind of really good vendor solution or the open source solutions which are crowdfunded. They are all good, but you really need them to have some kind of insight into your cloud environment. You also can use the default tools, AWS Security Center, GCP Security Center, Azure, Microsoft Defender in this case. They are all really, really good too. So just use whatever you feel most, but use them. And in the case you need expertise, you have experts around everywhere. We have the whole offensive security track, you have us, so just ask them, reach out wherever you trust. Thank you.